Hello everyone, welcome back to my channel, that is at CURIOCHEMISTry. So in this series of 6th standard new NCERT textbook, we are going to start 4th chapter, that is exploring magnets, which is similar to the old syllabus Fun with Magnets chapter. So let's start. Again, this chapter starts with one story. It is about the Reshma lives in a coastal town of Kerala and is very fond of writing short stories. So her grandmother loves listening to her stories. So Reshma was writing a new story to share with her grandmother on her 68th birthday, not 16. Okay. So the story was based on a ship carrying spices from Kerala for trade in the olden days. See how they have inclusively added little bit about the history also in the science. Okay, now Reshma was aware that in those days the sailors used stars to find directions at night, but in her story a situation arose wherein the sailors got caught in a storm with an overcast sky and stars were not visible. So Reshma could not take her story forward as she could not think about the how they are getting the directions, right? So she searched information on the internet on her school library. So she learned about the compass, a magnetic compass. Okay, so where here first time we got the name about magnet and which is used for the finding directions. So now it kept in one box, that is magnet keeper. Okay, so Reshma had seen pencil boxes, purses, but she cannot see this type of a magnet keeper. A writing board in her school also had a duster with a magnet, but she had never looked at those carefully. She now became curious about the means this is the introduction for the how you are going to understand about the magnet and where it starts. Okay, so here you are getting a curious about how this magnet works. That's why the chapter, the title name, the textbook has the name Curiosity. Okay, it changed, that is curiosity, where you are all the time curious about to learn. Okay, so they have given some examples, some common items that have magnets attached to them. Okay, so the magnet used by sailors in olden days were based on naturally occurring magnets and known as lodestones, okay, which were discovered in ancient times. Later on people found out that magnet could also be made from the pieces of iron. Nowadays we have magnets made up of different materials, and these materials are pencil boxes, stickers, toys, etc., even by artificial magnets. So the magnets can be various shapes. We have here bar magnet, U-shaped magnet, and ring magnet. Okay, so do magnets stick to object made of certain materials only? Yes. So that materials are divided into magnetic and non-magnetic materials, which we know already. So here they have given one activity that how you can understand about the magnetic and non-magnetic materials. So here are the list of these magnetic and non-magnetic materials, and you have to do this activity with the help of magnets, and you can write your observations and predictions here in this table. So what you got? So was your prediction correct for all objects? Which material stuck to the magnet? What conclusion can you draw? So from this activity we found out that some of objects were attracted to the magnet and to the and stuck to it. Okay, some are attracted to the magnet and stuck to it. So these materials are known to be magnetic materials. Okay, and which are the metal iron is a magnetic material, and with iron nickel is also there and cobalt is also there, which is a magnetic material. Okay, they are also magnetic. Now some other combinations with other metals are also attracted towards magnets. So the materials which are not attracted, totally opposite to the magnetic materials, so these are the non-magnetic materials. Okay, so from this list which are should which object should be the non-magnetic one? So here the if this scale is a plastic one, that will be non-magnetic. Even the candle, the cloth. Okay, so these are the non-magnetic. Even glass is there. Okay, and matchbox is also non-magnetic, right? So where you can, other than the material or the objects which are made out of metals like nickel, cobalt, or iron, they will be magnetic, and which are not, they will be non-magnetic. So now let's understand about magnetic in detail. Magnets in detail. So we know poles of a magnet. We know magnet has two poles, right? South and north. So for this, they have given one activity, that is, let us investigate the poles of magnet. So what you have to do, you have to take some iron fillings, that is very small pieces of iron, and take a bar magnet. And here you can see N and S, north pole, south pole. So what you can observe here, the iron fillings are attracted towards the pole. Here you can see more at the maximum at the poles and lesser in the mid size. So if we repeat this activity with magnets of other shapes, do we get the same result? Let's understand. So these ends of magnet are called to be the two poles of a magnet, north and south pole. Most of the iron fillings stick to the poles of a magnet of any shape. So it is not possible to obtain a magnet with a single pole, right? If a magnet is broken into pieces, again you will see the north and south poles to the broken one. So, which is in exist in a pair. Even in the smallest piece of magnet, it still shows you two poles. A single north pole or a single south pole cannot be exist. Now, how we can find the directions? So here you have to take one bar magnet and suspend like this, which have they shown a freely suspended bar magnet. Okay, so now mark the position corresponding to the ends of a magnet on the ground or a piece of a paper. You can understand that it shows the directions. Okay, it alongs direction along which the magnet comes to the comes to the rest. So what direction does this line indicate along which the magnet rests? How can we find out? So here, if we have noticed the direction where the sun rises or sun sets, we have an approximate idea of where east or west is, right? So hence we can locate the direction along which the magnet rests. So a freely suspended magnet comes to rest along the north-south direction, and the end of the magnet that points towards north direction is called north-seeking pole or north pole of magnet. Okay, the other end that points towards the south direction is called the south-seeking pole or the south pole of the magnet. A freely suspended magnet rests along the north-south direction because our Earth itself behaves like a giant magnet. So repeat this activity with a small iron bar in a place of bar magnet. So what you can observe? So does it always rest along with north-south direction? If it does not, then it can rest along any direction. This implies that only magnets rest along north-south direction. Okay, so this activity provides us with a way to test whether a piece of piece of metal is a magnet or not. So the property of a freely suspended magnet to always rest along the north-south direction is used to find the direction. So based on this, we are using, that is a small device is called magnetic compass. Was developed in olden days for finding the directions. So it has magnet in the shape of a needle. You can see here. This is a needle which is a magnet. Okay, which can rotate freely. The needle of a magnetic compass indicates the north-south direction. So the compass is kept at the place where we wish to go, and after some time the needle comes to the rest in the north-south direction. If you understood north-south, easily you can understand the east and west directions. So the compass box is then gently rotated until the north and south marked on dial are aligned with the needle. So now all directions at that place are as indicated on the dial. Okay, so how can we make our own magnetic compass? So they have given some activities. So you have to take a small circular box with a transparent cover on it, so you can easily look through it. Then the magnet in the shape of needle is mounted on a pin standing on the bottom of the box. So this needle is balanced on the pin in such a way that it can move around this point easily, and that is it can rotate freely. So the end of the needle which rests in the north direction is usually painted red. Here you can see. Then below the needle there is a dial with directions marked on it. So in this way you can make your own magnetic compass. So can we construct magnet also? Yes, we can construct. So for this we have one big activity here, making an iron needle a magnet. Okay, so what you have to do, take a needle and you have to rub the needle with the magnet. Okay, you can take any, not only the needle. You can take a cork piece, iron sieving needle, a permanent bar magnet, a glass ball. These are the materials. Okay, so instead of the needle, you can take any metal piece. Okay, what you have to do, place the iron sieving needle on a wooden table, then keep any one pole of the magnet at one end of the needle, then move the magnet over the needle at this length as shown in the figure. Then when it reaches the other end to the needle, lift it up. Okay, so it easily get lift by the magnet. Bring the same pole of the magnet you started with the same end of the sieving needle from the which you began, and repeat this activity for at least 30 to 40 minutes. Okay, 30 to 40 times. Then bring some iron fillings or steel pins near the needle. If the pins or iron fillings are get attracted to the needle, then it became magnet. Okay, now pass this needle through a cork horizontally. Float the cork in a glass bowl filled with water, such that needle always remain along the level of water as shown in the figure. So when the needle comes to rest, it shows you what? North south direction. So means we made our own magnet. Now attraction and repulsion between magnets. So as we know, magnet has two poles, north pole, south pole. Okay, magnet A, magnet B. You can see north south, north south. Then here magnet A, magnet B. So you will see that unlike poles of two magnet, that is north pole of one magnet and south pole of another magnet, attract each other. Okay, opposite attracts, we know. And the like poles, that is either the north or the south, they will repel, they push each other away. Okay, so we have one activity here. Let us experiment the take magnetic compass and a bar magnet. So the compass needle is also a magnet. Will it show the same behavior of like a magnet? So we are going to understand by this activity. So when the north pole of magnet is brought closer to the north pole of compass needle, it moves away. Yes, we know that the property that like poles repel each other. When the south pole of magnet is brought to the closer to the north pole of the compass needle, it moves closer. That is opposite attracts. Now, again one more activity is there. Observing the effect of magnet through non-magnetic materials means when you put here a magnet and a magnetic compass, in between a non-magnetic material is there. So what happens? Still they get attracted or not? So we have some other non-magnetic materials like wood, cupboard, plastic and glass. So what will happen? So we would observe that there is no appreciable change in the deflection of the needle when a sheet of any of the above material is placed between. So we can conclude that the magnetic effect can act through non-magnetic materials. Okay. Now, fun with magnets. After learning about magnets, Reshma was very excited and decided to set up some fun activities using magnets at her school fair. So what she made, some magnets can move some objects without touching them. Is it not amazing? So she made a magnetic garland by using the pins. We can make the steel balls out of the maze. Yes, we know this game. Even this steel paper clip in water, we can remove by the using magnet. Okay, so again we can make two matchbox magnet cars with like poles of magnet facing each other. So in this way we can use our knowledge in real life also. So in some magnets the north and south poles are marked as N and S. In other the north pole is indicated by a white dot. So sometimes the north pole of a magnet is painted red and south pole is painted blue. Okay. So how to keep the magnet safe? Yes, so we have a magnet keeper. Okay, do not hit me or do not drop me or do not hammer me. Okay, if you do this, then the magnetism of magnet will be destroyed. So we have to keep magnet in a magnet keeper. Okay, so what we have learned here, we have learned about the attraction between different poles, yes, and repulsion between like poles. And also we know about the shapes of a magnet, that is bar magnet, ring magnet and magnetic compass, again magnetic materials and non-magnetic materials, then poles of a magnet, that is north and south pole, U-shaped magnet, that is a shape of magnet. And what we have concluded that so many properties of magnets are there, and still we have to keep it safe as it is a magnet. We have to keep it safe in a magnet keeper. Then we can also understood about how to construct a magnet, then so many experiments on that. Also we explored and we investigate, we observed about the magnetic and non-magnetic material, and we also predict the materials according to their observations, and we recorded it. In this way we have finished this lesson, that is about magnets. Okay, so we'll stop here, and in our coming video we will see the next chapter. Thanks for watching.